microphone. Okay, this is Statistical Rethinking, second edition, chapter 15, and we're on question 15H6 down here. Okay, so we're going to return to a model previously in the chapter, the waffle divorce data set, but this time we're going to try to incorporate the entire DAG that was maybe discussed there, where age is affecting marriage rates, is affecting divorce rates, and that age is also affecting divorce rates. Right? So let's do that. Okay, so here I'm just copy and pasting from the chapter. Okay, so we have our data here, and this was the model that was ran in the chapter right here. Okay, and so here, you know, we certainly have that that D, which is say divorce, is some function of age and marriage. Now, in this case, you know, we know that that D has some measurement error, and so we're accounting for that measurement error here. Okay, you know, I won't go through the whole thing, but you know, we're saying that it has a true value, and that the true value has a mean of mu, and then we are parameterizing that true value based on these other predictors here. Okay. Now we also know that M has measurement error, but here it's not, you know, it's not being accounted for. Okay, and so so this is why we're going to try to use A to help make better predictions for M. All right, and so that's what we do in the next model. So I'm going to have to augment the data here. Okay, so I need to incorporate both the observed values for M and the standard deviation for M. Okay, here and here. All right, and so I just copied and pasted the model, but made some changes here. Okay, and the changes begin right here and end here. Okay, so what have I done? Okay, well, I've replaced in this linear model for mu of D observed, or D true, I should say. I replaced that with M true, and we're going to try to estimate M true. Okay, and how do we do that? Well, we say that M true is the mean of M observed. Okay, and that M true has its own mean, mu M, and that mu M has, you know, is a linear function that is being predicted by A. Okay, and so and then we just return to the, you know, the regular program. Okay, so this runs and this runs fine. They both run fine. But I thought that maybe we would also check the predictions between the two models here. Okay, so the first thing that I did right here, is this top plot here. Okay, so I'm just plotting the observations in blue, and then I'm plotting the predictions from the chapter model in black circles, and then for you know, this new model in red crosses here. Okay, so we get this image right here. Okay, so if you look at the, you know, the black circles and the red X's, you know, they're similar in most cases, but this isn't, you know, this isn't really the best view. I think what we want to know is, you know, are the circles or the crosses closer to the observed data? Okay, and so for that, I'm just going to take the residuals. Okay, so now I have the residual here between the predictions of the first model and the observed data, and that's again in black circles. And then I have the residual, which is again the predictions from the second model to the observations, and those are in red crosses. Okay, so if we look at that one, okay, we get this, and so now 0 here means you know, that a prediction is right on top of the actual observed value. Okay, and so, you know, you can kind of comb through here a little bit. My take is that, I mean, you know, we could quantify this pretty easily, you know, by summing the absolute value of the differences between them or whatever. But my general sense is that the red crosses tend to be closer to 0, which is to say making slightly better predictions than the black circles, which is to say the model in which we are imputing values for marriage rate based on age is doing slightly better in predictions. Now, of course, we have more parameters in that model, so whether or not it does better, like in WAIC or PSIS comparison, is another question. But okay, anyway, I think we'll call that good.